I think today we are going to have a demo session. First, we'll talk about mostly we'll talk about the contents that we are going to cover, and and then if time permits, I'll explain you a concept of DevOps. Okay, so I'm Fanindra. I have experience of training freshers mostly on Linux, Azure DevOps, and networking, Kubernetes, and these are the strong areas which I've been working on. And I'm still working. Like I'm doing this as my part time teaching because I have some interest in teaching. And I'm currently working as cloud engineer, Azure, GCP, and we work on mostly these technologies. Yeah. This course I've designed mostly for keeping in mind that whoever is going to attend this course have zero knowledge on IT. So I expect that you don't have any background of IT. If you are having it, good, and if you're not having it, you don't need like, you need not worry because we'll be covering everything from scratch. And the name of the course has is Azure DevOps, but we will have it in two parts or two phases. One is we'll have on-premise content, and once we cover on-premise content, we'll move to Azure and then Azure DevOps. So let me take you through what are the contents that we are going to cover. Um, so the first half that we are going to have is Docker and Kubernetes, the first half of the training. This training is going to be of 80 days. Like I need 80 classes to complete this training. So it might take somewhere around 3.5 to 4 months. So we'll start training maybe next week because I'm on PTO. So once we start it, we will like I'll take 80 classes, and out of which 40 classes will be till Docker and Kubernetes, that is on premise, and next 40 classes would be on Azure and Azure DevOps. Because if some of you are not familiar with Kubernetes and Linux, it is very difficult for to you to pick up DevOps, because currently in market Kubernetes and Docker is a very popular technology, and this is used for DevOps. And so the topics that we cover in the first 40 classes is we'll have introduction to IT. We'll see what is client server architecture, what is on-premise setups, what are virtual machines, and then we will see Linux. I'll explain you how does a Linux system boots. We'll go through some commands, some permissions. You will have to practice a lot. If you're not from Linux background, if you're not from technical background, there will be a lot of practicals. I'll show you each and every step, and I'll share with you the PPTs on the commands that needs to be done. And once I show you, you must practice, and that's one thing which I expect from your end. So we'll go through Linux commands, Linux permissions, how Linux is structured, and then we'll go through storage, types of storages, disk management, LVM. These are important. These topics I've kept it in the course because these you might use for mostly troubleshooting kind of things. When in DevOps also we'll have some agents where we need to troubleshoot the disk and storage. So no, due to that I have included the storage also in the course. Next is networking. We'll go through the networking. So any questions? I think I'm checking your comment section. I think anything related to cost and all, you can talk to the management. I'll be only helping you with content and the duration of the course. Networking, we'll start types of networks. What is IP address? We'll go through subnetting, okay, and routing. We'll go through some networking concepts like DNS, DSCP, NATing, NFS, network file share. So we'll implement NFS. We'll have practicals, and then we'll go for an on-premise deployment. So we will install an application server. We'll understand what an application server is. We'll deploy a web server, and we'll deploy database, and we'll try to bring up our own. We'll use Azure. We'll use Azure. Like currently first 40 classes we will have um first 40 classes we will have on premise, so we'll go through all the basics. So this is not related to any cloud. The first 40 classes we'll go through Docker and Kubernetes. And once on premise setup is done, like how to, once you understand how application server works, how web server works, how DB works, and what are all these, how you know uh, how to implement each one of this, we'll move to Docker. We'll see how to containerize the same applications. So we would have used some applications in on-premise deployment. We'll take the same applications and we will containerize it, and we will try to run it in Docker. Okay. Once Docker is done, we'll go to Kubernetes. Kubernetes is the biggest topic that is there, and I will try to cover it in the most detailed way possible, so that you don't have to take any other Docker or Kubernetes courses. And this is really important. We'll go through basics of pod services, config maps, volumes, the architecture, installation. We will have a setup in our laptop. So I would expect everyone of you. Yeah, I'll come to that. So we'll see AKS in Kubernetes also, AKS in Azure also, but most of the practices related to Kubernetes will be in on-premise. So I expect that every one of you have at least 8 GB of RAM laptop, so that we can set up Oracle VirtualBox or VMware workstation, and create at least 2 or 3 VMs and work on that. So the first 2 months is going to be that. We will do a rigorous practice on your laptops, and we'll install Kubernetes, we'll containerize applications, we'll try to deploy applications, we'll see how volume works. I'll show you NFS provisioner with Kubernetes, how NFS works, how ingress works, which is very important, and what are the other properties and deployment strategies. So we'll talk about all of this. We'll have, so all this whatever you're seeing in the slide now currently, these will take 40 classes to complete. So it's going to be mostly practical. So these are not related to any cloud. It is not related to neither AWS nor Azure nor GCP. So these I am taking because this is how IT has evolved over the past decades. Okay, if you see no, so if you see IT sector, this is how it has evolved. First Linux came, and then on-premise applications came, and then Docker, and then Kubernetes has come. So after you have this knowledge on Docker and Kubernetes, you can pick up any cloud. You can go and try to understand what is AWS and all. And yes, Lakshmi, I'm coming to that. And then once we have done with Kubernetes, we move to Azure. In Azure, we will start with introduction to Azure. We'll see before even moving to Azure, like the first topic in Azure, we'll see on-premise Active Directory. We'll see how Azure came up with Azure, and what is an on-premise Active Directory, what Microsoft was doing before coming to cloud. So we'll see that concept, and we'll try to understand on-premise Active Directory, and from there we'll try to understand Azure Active Directory, from and then cloud computing, pricing and structure, role-based access controls, your AD roles, Azure policies, what are the regions of Azure, how Azure is spread, and how to use those regions to create resources, uh, and zones. So I think someone pending group that there no sound. Am I audible? I think Murli, you
Yes, sir.
can. Yeah, I think Murli, you
Yes, yes,
can.
you're audible.
You're
I think
audible,
Murli,
yeah.
you can join. So we'll finish introduction to Azure. Azure is going to take mostly 30 classes, and then we'll have Azure storage. We'll see blob storage, file storage, and all the important aspect of storage of Azure. How to use it, how to have SAS tokens, redundancy, how to configure it, how to create it, and you will have to use maybe create a dev. I'll show you how to create a free trial account. You can create it and you can use it, and then we'll use go for Azure Compute. So since you would have already had an idea on on-premise, by the time we go to Azure, you would not feel, you will not have any difficulty in understanding the networking in Azure, virtual machines, how virtual machines work, because on-premise you would have configured virtual machines so many times. Uh, you will feel that how easier it is to configure the same in Azure. And then we'll see load balancer, virtual machine scale sets, app services, and Kubernetes. So we will go with Azure Kubernetes, but that won't be of much time, because you would have already practiced a lot in on-premise. I'll show you how to just do it in cloud. Um, Sainath has a question. Does it require coding? No. Whatever coding is required, I'll explain you, and you will not have any problem. So even if you're not from coding background, it is fine. As I said, I have designed this for freshers. This course. So keeping in mind that I expect that you don't have any knowledge, prior knowledge to anything. So that's how it is, and then we'll see backup and monitoring. We'll see how to do PM backups and monitoring of applications and alerts and everything. And then we'll see networking, some advanced concept of networking in Azure. We'll see some private endpoints, service endpoints, VPNs, firewalls. I'll tell you what is the right way of creating VNets in Azure. We'll discuss about hub and spoke models, and we'll discuss mostly on how Azure should be architected. Okay, we'll talk about cloud architectures here, and why only we have to prefer Azure? Why not AWS? I'll come to that. The reason we prefer Azure over AWS and GCP is, because of the of this factor, that is Active Directory. You see it here, right? Because every company that is there, every corporate, they use Active Directory. So whatever laptop you get from your company, you would log in with your company's credential. So now your laptop would be in domain, it would be added in domain with company's organization's Active Directory. And you use Teams, you use Outlook, you use everything from Microsoft, like OneDrive and all. So already, if an organization is using Microsoft product, it would be easier for the organization to expand it to Azure rather than expanding their services to AWS or GCP. So that's the ease with, that's the factor which has made Azure more popular than, AWS and GCP. And moreover, Azure DevOps, they have integrated everything in one place in such a, in such a beautiful manner, with same roles and responsibilities and users of the organization, that everyone is preferring Azure over GCP and AWS, because DevOps part is not there with AWS and GCP. If you talk DevOps with AWS and GCP, you have to go with third-party tools like Jenkins, Jira, uh, you know, other GitHub and all. But here already GitHub is a product of Microsoft. No, GitHub is acquired by Microsoft, so they came up with Azure repos, and everything will be in one window. So we'll talk about that today. Yeah, more, but times are changing. Like when we talk about job perspective, these days Azure DevOps is really picking up in the market. AWS has been there, no doubt. They are the first in the market. Whatever they have done, they were the torchbearer for this industry of cloud. But Azure is picking up really fast. But once you go through this course, that's what the first half of the course. I am not focusing on any cloud. So even if you want to go with AWS, I would suggest you go with, you first learn Azure and Azure DevOps and on-premise at least, and then you can read on your own for AWS and GCP. So when you are reading GCP, or when you are trying to understand how GCP works and AWS works, you will not feel difficulty in understanding those, because few terminologies might change, but the concept remains same. The way cloud works in the backend remains same. You will have to have knowledge on network. You will have to have knowledge on how VMs work. The UI might change, but what you want to do, what you want to achieve, if you want to deploy an application, if you want to configure an ingress, if you want to have a load balancer, the way you create a load balancer, the way you create ingress and application servers might be different from Azure, GCP and AWS, but the output is going to be same. For example, let us take example of Kubernetes. We will understand on-premise Kubernetes, and once you go through that, when we talk about Azure Kubernetes service, you will not have that much of problem in understanding Azure Kubernetes service. Similarly, if you go and try to read about AWS Kubernetes service and GCP Kubernetes, you will not have problem in picking up, because you already have a background of how Kubernetes works in on-premise. So that's my, that's the reason I'm not straight away jumping into Azure, and I'm not trying to teach here a product. I am trying to teach here, uh, IT, how it works, and how things should be. And after networking, we'll go through automation. We'll see some ARM templates. We'll see Azure functions. a few desired state configurations, and we'll close Azure. Once we are thorough with Azure, once we understand each of these, and then we'll move to Azure DevOps. Azure DevOps is going to be 10 classes, like only 10 classes. The reason Azure DevOps is going to be 10 classes, because by the time we reach Azure DevOps, we would already have had 70 classes talking about what to do, how to do, why to do in on-premise and cloud. So when we have that understanding of what we are doing, like when we generally, if you take any other sessions out there, if you go with anywhere else, just a moment, I'll mute. Yeah. So if you see Azure DevOps, you might see 30 classes, 40 classes. But the reason they take more classes for Azure DevOps is they integrate, they mix up everything. Like in Azure DevOps, they try to teach again Kubernetes. In Azure DevOps, they try to teach application servers, load balancers, app services. But by the time we reach Azure DevOps, you would have already idea on Kubernetes, app services, VMs, and that's the reason. Yeah, yeah, Azure DevOps will be sufficient, because by the time you reach Azure DevOps, you would have already 70 classes for supporting. So we will go through Azure overviews, Azure boards, repos, and then we'll see pipeline for .NET, pipeline for Docker and Kubernetes, pipeline for Java applications, pipeline for infrastructure as a service, that is ARM templates. So these days, Terraform is also picking up. We'll discuss about Terraform, and we'll discuss about CI/CD pipelines for Terraform. We'll see test plans, artifacts, Azure artifacts, and Azure load testing. So the reason I've kept only 10 classes, why it takes only 10 classes, because by the time we generally Docker and Kubernetes pipeline, you would have already practiced Docker and Kubernetes in on-premise. You would have already practiced Docker and Kubernetes in Azure, so you'll not have any problem picking up Docker and Kubernetes. And same goes with, we'll talk about ARM templates. We would have already practiced ARM template in Azure, and we would see how to implement that. uh, and so that's the reason it won't take much time. So this is how it is, and this is how the timeline is going to be. Almost 40 classes for Docker and Kubernetes, 30 for Azure, and 10 for few might be some little up and down can be there. I don't really stick to timelines, unless and until I am convinced that I have delivered the entire content. I'm open to extend any classes. That's not a problem. And yeah, so mostly it's going to be practical sessions. No, you don't have to go for Docker and Kubernetes separate training. You will have ample hands-on idea on Docker and Kubernetes. You need not go through trainings. Okay, clear? Any queries?
Is there any prerequisite for these classes?
Sorry.
Sir, I'm saying, is there any prerequisite for these classes to attend these classes?
Nothing, no prerequisite. You like you can will start everything from scratch. So you have to practice. I just request you that you at least dedicate some 6 to 7 hours a week apart from classes. You will anyway go through five hours of classes a week, and apart from that, if you can dedicate 6 to 7 hours, maybe over the weekend at a stretch you can dedicate, or daily you take 1 hour, but you should have that 6 to 7 extra hours. So total, if you can spend 10 hours for the next 4 months, a week, I think you will be in a good position to pick up things and practice on your own.
Sir, regarding these the classes before the Azure thing, so I just want to know, like, where are we going to practice it? Are we going to install these things on our local system, or like
Correct.
I mean to say, like, where are we going to install it? These like uh, the cloud where we are going to where will be the platform?
It will be in your laptops. In your laptops, there is. I'll explain you how do we install everything. So you'll have something called VMware Workstation. So in this, you will create VMs, and we'll practice everything in VMs, in Linux VMs, before going to cloud. So we won't be covering Ansible. We won't cover GitHub, GitLabs. We will cover only shell scripting. I'll teach you commands. if you practice, if you can practice more on that, you can do self scripting. Linux, yeah, Linux you will be thorough with. Linux will use CentOS 8 point CentOS 8.5 8.6 I think. I'll give you a version. CentOS will use, the reason I pick CentOS is it is closer to Red Hat, and Red Hat is the production Linux flavor that is used everywhere. So everywhere you go, you'll see Red Hat. That's the reason I picked up CentOS for all our practices.
So, Fanindra, one doubt actually.
Yes.
So, as you mentioned, actually, Ansible, this Jenkins, and these are all there, right? These are all not required in Azure DevOps.
No, Azure DevOps have their own tools, like the alternate. Ansible is a uh, it's for automation, like infrastructure as a code, and also we will see Ansible's we'll see ARM templates instead of Ansible. Ansible is automation tool, so basically, so instead of Jenkins there are Azure pipelines, instead of Jira there are Azure boards, instead of GitHub there are Azure repos. So there is, that's the reason people go with Azure these days, is they get everything in a single console. So let me just
Okay.
share my
Yeah, I got
screen.
your point. And in on-premises, Fanindra, so as you mentioned, when you are teaching Dockers and Kubernetes, you need to explain this one, right? Earlier, Azure pipelines and repos. Before that.
No, we'll first go through on-premise and then we'll go through pipelines, because on-premise came first and DevOps came recently. So DevOps is a recent phenomena. We'll go in a
Oh,
chronological order.
okay.
Python we'll use.
Okay.
We'll mostly use Python, Sanjay. Most of the demos we'll use Python. It will be closer to, because it is easier to understand. That's the reason I pick Python over other languages for demos. So if you, so whom do I suggest this course? This course is for anyone who has no prior knowledge on any of the IT concepts, or how IT industry works, or what things are. This is, I think, you must take it. And if you are already intermediate, if you already know Linux basics, if you already know Azure basics, if you already have worked on Azure or Linux, and if you're looking only for from a DevOps perspective, you want to sharpen your skills DevOps, then I would not recommend it, because because we won't be practicing a lot on DevOps, but we'll be practicing a lot on lot other things. So instead of focusing on any particular thing, I have decided, design it in such a way that you have the practice of everything possible, so that you can practice more on your own. So
Yeah, but Fanindra, but once this course is completed, right, we can
yeah,
try for the jobs. Is this is
yes.
sufficient,
So
or
what
we
are
need
the,
to do?
yeah, so what are the roles you can try? It is not only Azure DevOps role that you should try. You should try for a cloud engineer role as well. So cloud engineer, you can go with Azure administrator role. Okay, so uh, you can go to Azure administrator. You can go with Azure DevOps role. You can go with SRE role, site reliability engineering roles. Okay, where you deal with on-premise or Linux. So these are the three roles we are looking at when by the time you complete the course.
Okay. No, no. I mean, yeah. No, my question is actually, so after completing of this course, can we try for Azure DevOps role?
Yes, yes, definitely you should try for Azure DevOps role.
Okay.
That's what is the main
Will you
object, So
provide the certification for this course?
no, no. See, all the contents that I'm going to teach you, I have taken from Microsoft official documentation for AZ 900 and AZ 104. Okay, so all the
Hmm.
content I have prepared it from there for Azure. I'm talking. So at the end of this
Okay.
course, you should be able to take certification, and I'm sure you'll not have any problem in clearing these certifications. So these are Azure administrator roles, and you can go with AZ 400 roles as well. So for that you need to read a little more about the Scrum part, like how team is managed in it's a minute, Azure 400 exam. So you will have more concepts on how team is managed, a little bit of team management, and also if you read that technical part, I'll explain you. So you will not have any problem with clearing Azure AZ 400 with respect to technical. few things you have to read. I'll give you the links. You go through it, and you should be able to clear AZ 900, AZ 104, and AZ 400 examination. So yeah, and
Okay,
on
only
premise,
on Azure DevOps we have not we don't have like Azure Master like Azure 104, 204, 305,
ah,
400 like.
you have 400 for Azure DevOps.
Only
Sir,
400 is
which is the
enough.
latest one, sir?
Sorry,
Which is the latest version of the Azure?
this is the latest version of Azure. So Azure 400 is the certification for designing and implementing DevOps. So technical part will cover few things like let me show you, like you'll have to go through few theory part. You can go through this link. I'll just share so that you can cover this 400 examination also. Getting it?
Those exams are chargeable.
Yeah. Exams are chargeable. You have to take it from Azure website. So if your organization is giving you, a subsidy for this, you can avail that coupons. If not, you have to pay and take it.
Yeah,
Yeah, I'll
because
provide you.
nowadays for interviews they are asking like a certification also.
Yeah, you can do this certification. So is it 400,
Uh,
900, and 104? You can do the certifications right after that.
900 and 400 both are different, right?
Yeah, 900 is basic. It has more theory. What is Azure, how it works, and all. 104, 104 is will have some
Azure
scenario.
admin.
Yeah, it will have some scenario based questions. I'll share the dumps, and is it 400 will have DevOps based questions, and you can go with Kubernetes certifications also. After this course, you can go through it, and you can write, you can apply for that.
Okay. Any placement assistance?
No, I mean, I don't. I mostly focus on course and delivering the content, and maybe you can check with institute once if they have
Yeah,
references, they can give it.
yeah. Like in
Sir,
this
could you
course, any assignments or projects will be there?
Yeah, everything will be practical. Like from the day to day one, I think you will start practicing. So it will
Uh-huh.
be a continuous practice session, so we won't stop anywhere. So every day, whatever, I'll show you some demo, you will have to implement it on your own, and you have to practice it. So everything is going to be practical. So I won't. There will be some theories here and there, but yeah, you will get recordings. So just in case if you miss the class, you will get
Hmm.
session recordings. You can go through it the next day, and you can practice. And if you face
Okay,
any difficulties, maybe we can connect after the class every day, or
okay.
over the weekend if I get time. I
Yep.
connect and clarify.
Yeah. What are the class timings?
Class timings are 8 to 9 every day evening. They generally I don't change timings, so it's going to be 8 to 9. So if I don't take any, if there is no class any day, I put it in the WhatsApp chat minimum an hour, 1 hour before that there won't be any class.
Okay, thank you.
Yeah.
sir, will there be any projects or something? Like, are we going to do any project?
Sorry.
Are we doing any project?
Sorry. 1 second. I think
Sir, I'm saying, are we doing any project here?
not specifically one project. I pick up use cases and we try to implement. For example, let me give you an example. For example, when we talk about on-premise setup, um, okay, so we will be working on this architecture. We will create one app server. We'll create one DB server. App server will make sure it connects to DB for writing some data, and we'll create one more app server which talk to the same DB for writing data. We'll have web servers which routes it to different app services in the backend, and we'll have the client like we accessing the web server. So I have designed these scenarios similarly, and we will be implementing. So VM1, I'll tell you that implement these two, VM2 implement these two, and this is how it works in production. And that's how I design scenarios based on my experience on production deployments and how things are, and we work on that. So for example, if you pick up Kubernetes also, we'll be working on some architectures, so picking up use case, and so that you really understand when we use that and where do we use that uh, things. So let me just share that. So we'll be mostly talking on, no, I'll share you PPTs where we'll have mostly design. So I'll tell you that you have three worker nodes, keep application one pods and two worker nodes, mount these folders. These folders should be mounted for these pods. These folders should be mounted for these pods. We'll pick up, and I'll explain you how do we create PVCs and access storage and everything. So I'll tell you what we are doing, why we are doing, how we are doing. I'll implement, I'll show it to you. You have to make sure you practice it and you replicate it. Same goes with Azure DevOps also. So when it comes to Azure DevOps, we'll have projects. I'll give you code so that you don't have to write code. So for example, if it is .NET repository, I think I'll just pick up some code. Repos. For example, if it is Terraform, I'll show you how to write code. I'll give you examples of code. You can push it, and then we'll see how to write pipelines, different pipelines, and then you can go through it. And for example, this pipeline, or we'll pick up something else, Java pipeline, if it is Java pipeline. So this is how the code is. I'll explain you how to write it, or how it is generated, how to edit it, and how to improvise. Clear? Getting my point? And same goes with Azure. So I pick up scenarios for Azure as well. So how networking should be in Azure, how to implement firewall, and if you see, let us take an example from Azure as well. So when we go with, so this is how I design. So this is the, we'll create one VNet, we'll create firewall, we'll create another VNet in some other region, third VNet, and we'll deploy VMs in VNet, and we'll peer the VNets. We'll create route tables. The routing should be there. So these are actual architectures which we use in when we deal with production setups. So this is how we design architectures, and this is how it is implemented. So uh, that's how we do it. And like this, I'll pick up scenarios and we'll be working on individual scenarios rather than a one big project. So we'll pick up small scenarios and work on it so that I can show you all the features. And if you know all the features, when the time comes, you can implement the feature depending on the situation. Clear?
Sir, any tips about interview questions while teaching?
We'll be talking with we'll be talking about interviews and know how questions might come, what might be asked when we are discussing classes. Like in each class, I'll be explaining you, this might be the questions. This is how you might get it. So that's how it
And
is.
what are the role? What are the roles we can apply for like after completion
A-
of this course?
Azure DevOps engineer, cloud engineer, or cloud administrator, Azure administrator, Kubernetes administrator, and yeah, I try to mute everyone. I think. Yeah. So yeah, I muted. Yeah, cloud administrator, Kubernetes administrator, Azure DevOps. So these are the three roles you can look for, or cloud engineer, or you can go for SRE also, site reliability engineering. So these are the few roles you can apply for.
Yeah, Phanindra, I have one doubt. Why we had to choose Azure? Why not like AWS and GCP?
See, if you are more interested towards AWS and GCP, we have AWS with DevOps course. So there, where there you will learn AWS, you learn Jenkins and other
No, I want to
tools.
learn Azure only.
Okay. So
But
so the reason.
AWS, hmm,
Okay, so yeah, let me explain you why DevOps, what is DevOps, and why Azure is, how Azure has come up in DevOps. So generally, when we discuss about DevOps life cycle, so generally a customer comes with their requirements to client, like to IT companies. Now they come with their requirements saying that I want to develop an app. For example, they want to develop a app which delivers grocery, like Blinkit or Zepto or
Big
Swiggy.
basket.
Okay. Now Now they will know the someone from the company side, business analyst or product owners. They translate the requirements into smaller units. So for example, if they have to build an app like Zomato, then it will be divided into a lot of smaller units. So you can't simply bring up an app over day. So maybe menu section, menu pages, my orders, my cards, payment details, card details. So these are the smaller units which your application would be divided into. And once it is divided, it will be kept in some backlogs. So it will be written down. Maybe in an Excel, they'll write it down. What are the smaller units which must be created so that the app comes out in the end. And once these are created into smaller units, the engineering team or the Scrum masters, they would do the capacity planning. They will see, okay, these are the units which must be developed, and this is how the sprints must be. Okay, in first sprint we are going to develop the front end of the app. In the second sprint maybe back end. Third sprint maybe we'll integrate with payment gateways. Fourth sprint we'll add a feature of adding to cart. So like that they'll do a capacity plan. Okay, we have 10 engineers, so 10 engineers can work for 6 hours a day, and they can accomplish this. So this is what we'll put it in our first sprint. Sprint is generally 2 weeks. So 2 weeks of period is called sprint. Generally it is 2 weeks. You can change also. So they put it in a sprint saying that okay, in 2 weeks we will do like this. And the reason people have come to sprints is earlier how it used to happen a decade ago. When customer had a requirement, suppose you have to develop an app, they would come to some company, Infosys, Wipro, or any company. They would give a requirement and they would do a sign off saying that okay, by the end of 1 year you would deliver me the application. Okay, and they would, once the contract is signed, the company would start working on it. Engineers would start working on it. They'll have timelines. They will have 1 year to develop the app and give. So at the end of 1 year, when the company used to hand over the application to the customer, it might be possible that customer was expecting something, but something else came out of it because of his expectations, and the output did not match. The second thing, maybe customer doesn't have the requirement anymore. 1 year is a long time. Maybe customer wanted to develop that app 1 year ago, but now the customer does not have that requirement. The requirement has changed. Number three, maybe the app is working just fine how customer wants it, but customer is customer few features are not as what it is expected. So there is always a difference in opinion when there is a lot of time in between. A lot of time is given in between the requirement gathering and the delivery of the product. So that model of development was called as waterfall model, and slowly they have come up with uh, the Scrum based model or Agile based model, where they develop everything. You know in a shorter span, and they continuously deliver it to customer. It's not like at the end of 1 year you will get the product. Every 2 weeks they'll show the progress. Okay, these 2 weeks I have done this, are you satisfied or not? So this is what DevOps is all about. DevOps has come out of this mindset. So DevOps is not a set of tools or set of technologies. It is more about mindset of people. It is more about how people work and deliver in an development and delivery manner. Now, once the capacity planning is done, the developers will pick up the backlog items. It could be bugs, it could be some feature which must be developed, and they will start developing. They will start writing the code. It will be assigned. Say some developer, it will be assigned that okay, in 2 weeks you have to finish this. So based on his timing, his or her, so it's his or her comfort, they will develop it for 2 weeks, and they would put it or they would commit it to the. So once they develop it, they would test it in their local. So what do? Once you write a piece of code, you check if it is working or not. So that's what developers will do. They will check if it is working in their system or not. But now, since we want to develop a one single app, that is one Zomato or Swiggy app, only testing in their own system is not the solution, because you are not going to deliver only one person's work. You have to collect all 10 developers work, because you have divided into 10 developers, right? One application we are divided into among 10 or 20 developers. Now you have to collect the 20 developers work, and you have to test it. So developers will anyway test in their local, and then they will need a central place where you put your code. Now that's how your repositories have come up. Now you see GitHubs, Bitbucket, and all these online repositories. They have come up because you need a place, central place where all the 10 people, 20 people, 100 people, 1,000 people, or 1,000 developers who are there, they must commit their code. They must merge their code so that collectively they can deliver something to the customer. Now, once they commit it to the central place, central repository, there again we have to do testing. So before, testing was done by individual developers in their system, but now we have to test all the code, like all 20 people, 20 developers code once again. We have to again build it. We have to again test it. So this is where your Jenkins came into picture. We had CI pipelines, that is continuous integration. When we say continuous integration, what does it mean? So when we have the code in the repository, we should have some piece of code which is building and testing. Because if you have again people to build and test it there, it is again a waste of effort, because developer might push at any time. One developer might push it today, some other developer might push it tomorrow. There might be any change at the midnight. Okay. Some developer is working late nights, some developer is working early morning. They are committing code as per their convenience. When they're committing code to the central repository, there has to be some piece of code which is automatically triggered, and which does the build and test for entire code base. So once we collected 20 developers work, we tested it today. Tomorrow morning, if out of 20 developers, one developer will do some small change, even if he's changing one line of code and again committing, we have to again test the entire code with all 20 developers work. So that's why we need to have this some script which is building and testing the code, and then we have to save the output. So always when we build something, we will get an system, the code is written in human readable format. But when we build it, it is converted into system readable format, how your system, or your computer understand it is converted. Like, it could be output could be a jar file, output could be a NuGet package, output could be a Python package, it could be any type of package. Or output could be simply a zip folder. You zip everything and you get an output. So the output is stored at a central place, from where you deploy it somewhere. So once you have built your application, you have to run it somewhere. Okay, it could be a VM. You can deploy it through a simple virtual machine. We'll talk about it. VMs, what are virtual machines, what is deployment. A few words which you are not understanding today, you will understand by the end of this course, that I am confident about. So when you deploy it somewhere, it could be VMs, it could be AKS cluster, that is Kubernetes cluster. You can deploy it to Kubernetes cluster. You can deploy it to PaaS services or application services, or serverless. Nowadays we get serverless compute. You can deploy it there. So any target you can deploy it. So how does generally deployment happen? We generally deploy it first to development environments like VMs, Kubernetes, or PaaS services. From there, your testing team will test it. They'll check. So whatever test you are seeing here, these tests are unit testing. So if code is proper or not. The testing team which tests here are manual testers, or we use manual testing to test if output is how it is expected or not. If the UI is how it is expected or not. For example, if the color is same as what is expected or not. If UI is same as expected or not. So testing team will test all of that, and if they find any defects or any bugs, they will again update in your Scrum, or update wherever your Scrum Master is managing the backlogs. It could be Excel sheet, or it could be any tool, Jira. So it could be a Jira tool where the testing team will update the bugs. From there, your developer will again pick up. So this is a continuous process. That's the reason it is called continuous integration and continuous deployment, because continuously we're integrating the code with the central repository and continuously we keep on deploying it into different environments. So deployed generally to first development. Once it is deployed to dev environment, and testing team does the testing, and now the testing team is satisfied. For example, after 2 weeks, testing team is satisfied saying that this is what is expected and I am satisfied with it. Then your code will be promoted to next environment, that we call it as UAT environment. There also it will be same replica of dev environment. If it is VM, it will be VM. If it is Kubernetes, it will be Kubernetes. It will just be promoted to UAT environment, where the access would be given to your customer. So your customer, there will be some people from your customer side who will now test how the application is coming out. No, because they are the one who gave requirement in first place. So they will have the access to UAT environment. They will check it. If the output is how they are expecting it, if it is not how they expect it, they'll give an immediate feedback to your product owner saying that this is what I was expecting, but this is not how it is coming out, and I want to change this. Okay, so based on the inputs, again, the requirement would be taken into taken into consideration by Scrum Master and divided into backlogs, and your developer picks it up, and this cycle continues. And once your business team from your customer end is satisfied, saying that I am satisfied with this output, and I want to give it to my client. Suppose you are developing an application for Zomato. Who are Zomato's client? The general public who is using Zomato application, right? So they, once they are satisfied, once Zomato is satisfied, they will release it to production, which will be used by their clients. It could be general public, it could be specific public, which we call it as prod. Now where is CI/CD coming into picture? CI/CD is coming into picture in integrating. So so before introduction of Azure, Azure DevOps, people use Jira for Scrum planning. They used GitHub for repositories. They use Jenkins for CI/CD pipelines. And instead of this cloud dev UAT prod, whatever this is happening, they used AWS or GCP, mostly AWS. So, but after Azure has come up with Azure DevOps platform, these Scrum related planning and everything, Jira related things are being replaced by Azure boards, where you can have everything planned, structure, do capacity planning, track the backlogs, track the workforce, track everything what is happening. This repository is replaced by Azure repos, where you commit the code and you keep a track of it. And this build pipelines has become Azure build pipelines, the pipelines, and deploy pipeline. And these the central place where we store the output is Azure artifacts, and deployment are Azure release pipelines. And these tests, whatever people do, they have been replaced by Azure test plans. Getting it? The reason why Azure DevOps is so popular, because whatever complete end-to-end life cycle that happens in any organization, that is covered by 5 different tools or 5 different features of Azure DevOps, which are used at different phases of application development. Okay, so if you look at Azure DevOps, uh, you know we take it Azure DevOps, they'll have projects. In projects, you'll have 5 features generally: boards, which will have backlogs, bugs, and you can have who is assigned to what, who is working on what, sprints, sprint plannings. In repos, we will have again repository commits, pushes, who pushed it, branches, pull requests, like merging the code. Pipelines, we will have build pipelines, we'll have release pipeline. If you look at release pipeline, you will have different stages of release pipeline. We do stage wise deployment. Suppose this stage is dev. Okay, uh, and the best part is, with why Azure DevOps is picking up one more thing is, we can by default deploy it into Azure App Services or Azure Kubernetes services, deploy to Kubernetes services from here. It is really easy. Suppose example, we say this is UAT. Okay, and we can have approval based deployments. So I can say that approvals are required, and I can give who can approve it. And these users are your organization's user. So when you have an organization, you cannot escape from Microsoft, because you will have a Microsoft Active Directory. You already have users. That's how you manage. You manage Outlook, you manage Teams. So these are the users from there. So by default, you can give your team members name or manager's name, who can approve the deployment, and who can, disapprove the deployment. So you can have test plans. You can write test plans. Who can implement these test plans? You can assign test plans. You can create artifacts. You can use them. So we'll go in detail when we discuss more about this. So this is how, we have complete life cycle. So this, whatever we have been talking, this is called DevOps life cycle. And that's how Azure DevOps is picking up and replacing the existing technologies, because you get everything in one page, complete end-to-end management of development and DevOps lifecycle.